Ever find yourself like really sucked into a logistics game? You know, the kind where you're moving stuff around, optimizing routes, and you're just kind of amazed at how the computer always seems to know the absolute best way to do it.
Yeah, totally.
Well, today's deep dive is like gonna crack open the hood on that mystery. We're taking a look at the world of automated planning algorithms,
Mhm.
specifically a system called it's called Fast Downward.
Okay, yeah. Fast downward. This is a good one. What's really cool about this, right, is that it's not just like crunching numbers blindly. It actually tackles these complex problems in a way that's surprisingly similar to how our own brains work.
And that's what gets me so pumped about this stuff. Like, are we really so different from these algorithms? Anyway, we're diving into a research paper today, explains how Fast Downward works, and trust me, it's way more interesting than it might sound at first.
Oh, for sure.
Yeah.
It really gets you thinking. And what the paper highlights really well is how we actually present a problem to a computer.
Hmm.
Like that can make all the difference in how easily it can be solved. It's not always about just having more processing power.
So it's kind of like instead of bombarding the poor computer with every tiny little detail, it's about giving it the big picture, right? Let it see the forest for the trees.
Yeah, exactly. You got it's like think about it. Imagine you're trying to explain a route to someone. You wouldn't like list every single crack in the sidewalk, would you?
Right. Huh?
You'd use like major landmarks, right?
Right.
Broader directions, given the lay of the land.
You're saying it's all about that sweet spot. Enough
Yeah.
info to be useful, not so much that it gets overwhelming.
Exactly. And that's where these multi-valued variables come in, which
Yeah.
the paper dives into. Fast downward uses these broader variables to understand like the core elements of a problem without getting bogged down in all the tiny details.
Okay, so walk me through this. Give me an example. Let's stick with that logistics game idea. Keep it concrete.
Okay, sure. So instead of tracking, the exact location of every single package, every truck, every second, Fast Downward might just say, okay, package A needs to go from city X to, we'll say, city Y.
Okay.
And these broader strokes, they become like the building blocks for his plan.
So it's like using those multi-valued variables is like, it's like giving Fast Downward this superpower. Suddenly it can zoom out, see the big picture,
Right.
strategize at a higher level.
Exactly. And that's what makes it so much faster than those older planning systems that we're stuck dealing with. Like all the little nitty-gritty details. It's like,
Yeah.
it's like
Yeah.
Fast Downward is playing chess, right?
Yeah.
And these other systems are still stuck figuring out checkers.
Love it. Okay, so I think I'm starting to get how Fast Downward gets that that edge. But how does it actually go from those big picture variables to an actual plan? How does it like connect the dots?
That's where it gets really elegant, really clever. The paper dives into this thing called, get this, domain transition graph.
Domain transition graphs.
Yeah. Sounds complicated, right? But bear with me. It's actually super intuitive. Basically, it's like, imagine, those choose your own adventure books.
Oh yeah, loved those.
Right. So picture that. But instead of you making the choices, it's all those variables we were talking about.
Yeah.
So let's say our trusty truck variable, right? It's currently sitting in city X.
Okay.
The domain transition graph, it lays out the options. Like it could stay put in city X, or it could maybe make the move to city Y. Each of those possibilities and the conditions that make them doable, they become like a branch in this graph.
So it's like Fast Downward is making a map of all the potential moves in this logistics game,
Yeah.
trying to figure out all the possibilities.
Precisely. But, and here's the really cool part, Fast Downward isn't just blindly following every path on that map. It's not just, randomly trying stuff. It wants to find the smartest path, the most efficient one. And to do that, it needs another trick, another tool in its toolkit.
Wait, so just finding a path that gets the package delivered?
Yeah.
Like, that's not good enough. What makes the smartest path so special?
It's all about, understanding the relationships between those actions, those variables. The paper calls this they call it the causal graph.
The causal graph. Okay, so this is like connecting the dots between those choices on the map. Is that it?
You got it. It's all about seeing how things influence each other. So let's rewind back to our truck, right? A simpler planning system. It might see a path on that map. It might be like, boom, we could totally move that truck from city X to city Y. We're good. But what if, maybe, that truck doesn't have enough fuel?
Oh, right. Yeah, that would be bad.
Haha, exactly. A human player, they wouldn't make that rookie mistake.
Yeah.
And that's where this causal graph comes in clutch, right? Fast Downward uses it to understand that, hey, moving the truck, That also impacts how much fuel it's got left. And fuel, well, that's essential for movement. You can't just ignore that.
It's thinking several steps ahead, right? Just like a seasoned, logistics expert would do. They wouldn't make that fuel mistake.
Yeah, totally. And this kind of thinking, it's not just for games. It's huge in the real world, too. Imagine, like, a robot working in a factory. It's using fast downward to plan its moves. That causal graph, that's what helps it dodge, like, costly mistakes, make sure its actions always make sense, logically.
So we've got these domain transition graphs, right? They're mapping out all the possibilities. And then we've got the causal graph, double checking everything, making sure those possibilities are actually like doable. They're actually going to work. It's like fast downward is, I don't know, a master chess player or something. Always thinking several moves ahead.
You got it. That's a great analogy. But here's the thing. What happens when that chessboard gets, like, insanely complicated, like way too much to keep track of, even for a supercomputer?
Okay, yeah, you've definitely got my attention now. What happens when things get too complex, even for, a whiz kid like fast downward?
Well, the paper mentions it's a really fascinating concept. It's called, they call it pruning. Pruning the causal graph.
Pruning?
Yeah, pruning. Essentially, it's a way for fast downward to, like, simplify things a little bit when it needs to, without totally throwing its plan out the window.
Pruning, huh? I don't know. That almost sounds like, cheating. Like, is it allowed to do that?
No, 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 not at all. It's not cheating. It's more like strategic decision-making. Think of it this way, like, if you're driving to the grocery store, right? You don't need to, like, mentally map out every single side street, every little alleyway on the way, right?
Right.
You're focused on the main roads, the essential routes that, actually get you where you need to go.
So fast downward is what? Finding those shortcuts, those main roads in the planning process?
Exactly. It's all about streamlining things without losing sight of those crucial dependencies, those things that absolutely have to happen.
But how does it know, like, which corners it can cut without messing everything up? That seems like a super delicate balance to strike. It's like fast downward has some internal compass, like it knows which connections are like those non-negotiables. It can't mess with those even when it's trying to simplify things.
Yeah, a great way to put it. And the paper actually uses that example, the truck needing fuel, to kind of illustrate this.
Yeah.
Even when it's doing that pruning thing, simplifying its causal graph fast downward, it still remembers those absolutely essential relationships.
Okay, yeah, that makes sense. It's got to play by the rules of the game, right? Even if it's taking a few strategic shortcuts here and there. But it makes me wonder, are there ever times when even this, this clever system, it hits a wall? Is fast downward truly unbeatable?
Well, let's just say there are still some areas where us humans, we still, hold our own. The paper, it does point out that fast downward can sometimes, stumble a bit with problems.
Yeah.
Where the order of actions is, like, absolutely mission critical. It can't just mix things up.
Oh, okay, I see what you mean. It's like, what's a good example? Oh, it's like in a recipe, right?
Right.
You can't just go throwing ingredients in a bowl in any old order and expect, a perfect cake to just magically appear.
Exactly. There's an art to those really delicate, sequential processes. And that's something even the smartest computers, they haven't quite cracked the code on that one yet.
Huh. That's oddly comforting, actually. It's good to know that even in this age of, super smart algorithms and all that, we humans, we still got a few tricks up our sleeves.
For sure. But even though it's not, perfect, this whole idea of how fast downward works, it can actually make us better thinkers, too. It's like getting a peek behind the curtain, seeing how a strategic genius actually tackles a problem.
So what you're saying is this whole deep dive, it's not just about some, fancy computer program. There's actually some real takeaways here for how we approach problems in our own lives.
Absolutely.
Yeah.
Next time you're facing some big, hairy challenge, right, try thinking like fast downward for a minute. Break it down into those key variables like we talked about. Try to map out how they all depend on each other. Look for those, those efficient paths to your goal.
So channel my inner algorithm. I like it. Thanks for the brain upgrade. And for you listeners, keep this in mind next time you're wrestling with some super complex task, right? Whether you're planning a trip, organizing a project, maybe even just trying to conquer the mess in your closet, remember the lessons of fast downward. It's all about strategy. That's it for today's deep dive. But hey, the learning never stops, right? Until next time, stay curious out there.